but mainly is switches and kind of proximity sensor that they have used in their system. But after year by year, then when I was in CCM in year 2009, that is where that we are a bit more exposed into yield process and control system of a plant, which really help the plant to run in full automated system and giving a lot of benefit to the organization and also people that involved, basically chemical engineers, the plant operator, technician, and other engineers in plant, so that we could operate the plant safely and also economically. I hope that my voice could be heard along the way. If couldn't hear, I mean, you should highlight to me.
Yeah, we can hear you. We can hear you nicely.
Okay.
Okay.
All right. So that's a bit of the background. I'm not the expert in the process control and instrumentation, but I have been working with process control and also instrumentation system since then. So I do not have what do you call that, technical, a very deep technical aspect of process instrumentation. But what I'm sharing is basically, what is the why we need process control and instrumentation in industry, and also a little bit of examples in previous plant in CCM Chemical, that in terms of the selection of a few of process and control instrumentation that we have earlier. Why I selected CCM? Because the environment was I would say at very the nature of operation of the plant is basically because you are producing acid and caustic. So that was the extreme condition that where and instrumentation also is still working in that situation and condition with the expected failure rate, which is quite low. Yeah. So from there, we will be able to understand that by doing the right selection, we still able to have a process control, even though the situation or condition of the plant at an extreme condition. Okay. I will share this presentation slide. Yeah, just hold on. But I just would like to make a claim here that this presentation slide is basically I obtained from a shared server. So it is belongs to some other person, but the knowledge could be shared, because it is already obtained the approval from the person.
Dapat share ke cik tu?
Sharing that. Okay, can we see the screen?
Yes, we can see the screen.
Just turn off this one. Okay, so just focus on the content of the why process control. This is the only subject that I'm going to touch today because we do not have also much time. So why process control is important and why we need process control. Okay. So the first thing that when we when we talk about process control, then we will come to the safety of equipment and also personnel. Okay, safety is basically is the main focus and main thing that when as a as a, as a as an engineer, regardless of any engineer, and when we are working in industry, safety will be our first and foremost thing that we would like to take into our consideration whenever we design anything. We have learned from many years from decade ago that is a lot of major accident, major industrial accident that have happened due to lackness on the safe operation and also design. And that should basically be our drive and also our motivation uh, in current environment to ensure that we had the lesson learned and also we improve from time to time. Therefore, the safety of the personnel, the people, the asset in our plant is in a very safe operation manner. Okay. Next will be the production specification of quality and also quantity. This is also why we need process control. When we talk about production specification of quality, the focus of quality and also quantity. So after we talk about the safety of equipment and personnel, the next thing is, of course, industry is meant to make profitability. The that is why we are here working in any field that we have is basically to create values. So it's about quality and also quantity, where we supposed to achieve the good quality and also we have efficiency. When we talk about quantity, is basically the efficiency of our operation. The third one will be operational constraint. We know that for us to produce, to convert the raw material into product, there are a lot of constraints that we have, that we sometimes could not rely everything to human being. So yes, we need people, but some of the job is 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 not practical to be carried out by people. So therefore, we need process control and also instrumentation to help us to oversee those sub processes. And number four will be the environmental and also the law, okay, the legal requirement. We know that a few years back in Johor, in Pasir Gudang, we had Sungai Kim Kim issue. So after that issue, there are a lot of changes in the legal requirement to operate a chemical plant. So that here also we see that a lot of effort has been put basically by industries to ensure that the environmental and also environmental aspect and also condition is being taken into account. Therefore, we operate the plant, the industry operates at the same time, environment also is taken care, as it is also our responsibility to ensure the environmental condition, not only it is taken care, but it's not being jeopardized. And also finally will be the economics. Okay. So this will be more into economics aspect of process optimization. That is where also we use process control sometimes in plant operation to have to reuse energies, heat transfers, to get so that we do not waste any source of those energy. Okay. Just imagine that we have a stream. This can be a distillation column. Yeah, and you have few feed and also few other streams. So when we see about safety of equipment and also personnel from this diagram, we know that this process involves heating, and also you have a process column which may be very expensive, and you have equipment such as pump that may cost you about a lot of money, about maybe 20,000, 30,000, and a process column which is very expensive. Okay. So just imagine that we have such a system in our operation, and people, how difficult it will be in terms of the operation that we have here to achieve, end of the day, good product at this output of this column. So this is where that you see the process and also controls and instrumentation system comes in and basically take care the safety of the equipment and also the personnel that involved here. So I will just scroll to give example. See. So as an example here, you have this statement here telling that high pressure in drum is dangerous. Okay. So what would happen if high pressure in this system? So the drum may explode if there is no proper process design is in place, or we tend to depend to human to monitor. Okay, so that is where that the process control and instrumentation will help in terms of the monitoring of the system to ensure that there is no high pressure occur in the drum. So from this case, you have control valve link into the pressure control system. You can have the pressure control system to take care of the pressure that you would like to maintain in the system, and at the same time, if there is any overpressure or under pressure, the control valve will be able to release or to contain pressure, so that you can achieve both the vapor product and also the liquid product specification. Okay. Should you have any question, maybe you can just raise up your hand, and instantaneously you can ask during the presentation.
Okay, any questions so far? Saya rasa okay kot so far. Dia belum masuk yang the highly technical things lagi.
Okay. Alright. Okay, so I will just go to the next example. Okay. The next example that I have here, also same, in terms of safety of equipment and also on personnel. It says that the no flow could damage the pump. Okay. So it is very important to ensure that the level in the drum is being maintained in the appropriate level. Okay. So you will have a level transmitter, having a loop into the outlet of the outlet stream, which is being controlled by a control valve, and also the pumping system. Okay. So how does it work? Is basically the level in the drum will be translated, into the sequence of the pump operation. So if you have the level going up at a certain high level situation, the pumping rate will be increased. Therefore, you can release more product. But whenever the level reduce into a certain lower threshold, the pump system could be throttled down and reduce in terms of the speed and also pumping rate. Therefore, you can build up again the level. So just imagine that this operation, if you need a person to manage and control, that will be very difficult, and also and will be very, very tedious, and the operator also, I think, will not stay long in the area of working. Yeah. Right. So there's another example, and on the product specification of quality and quantity. Okay, so this is where the important to control the feed rate, into the drum. Yeah. Therefore, you can achieve the quality and also the quantity, the right quantity of the product. Okay. So the control system could be designed, even though you have multiple parameter across, like temperature, flow, and a few other temperature indications, where it always could be cascaded between each other for you to achieve the right quality and quantity. Example, you need this flow at a certain temperature, and also a certain feed of the steam or the processed fluid. So the control system could be designed accordingly. Therefore, you can have a cascade system managing this. So you need to basically understand the amount, the numbers of loop in the system, which I think that many of you have gone through during the studies. Just to check, Doctor, they have taken process control and instrumentation subject, right?
They are taking it now.
Okay.
So
So
they know about the control, identifying the control variables, manipulated variables,
okay. All right.
measurements. Now they are learning about instrumentation,
Mm-hmm.
selection of instruments.
Mm-hmm.
So they have a project on that.
Okay.
Yeah.
So I think that in terms of selection of the loop, understanding the variable and also the manipulated variable, you all will have to you all have gone through in your studies, which it will be beneficial for you to understand those. Therefore, a proper process loop could be designed here to achieve the quality and also the right amount or the quantity to be controlled. Okay, so this will always keep the production rate smooth. Why we need to keep the production rate smooth is very important, because when you are running a chemical plant as a process engineer, if you have the process which is having a lot of disturbance and which is not smooth, like end of the day it basically will impact the yield and also the productivity. It will be in a situation that um, uh, the the you will not be able to utilize the plant capacity. The utilization rate of the plant will be lower. So this will impact in terms of the profit and loss of the company if you do not have a good and also smooth production system. And it will be also a waste to the feed material. Uh, Basically, when you have off-spec product, and that you need to rework those products, so that will be considered a lost time, which you need to again to rework those material to make a good product. All right, so we'll move to the next slide. Okay. So you also can determine the quality, specifically on the quality of a product, by measuring the intended quality parameter of product. Example here, maybe like concentration of a product, and it require certain heating from the process to achieve a certain density or concentration. So a single loop of this also could be achieved directly before the final product. Therefore, it can be adjusted accordingly to give you the right ratio. Okay. So we have a lot of process control and information. Basically, is adding this knowledge is basically adding a lot of value into the operation of a chemical plant. Okay, so in terms of environmental and other regulation requirement, so we know that we should not release any hazardous material into the atmosphere or into the environment. We can have many examples here. So, why we shouldn't release, because that all these chemicals are hazardous, and also it will impact the environment, not the environment, but whoever that living in the environment. Whenever I say that whoever is living in the environment, it is including all the living creatures, including human being, animals, trees, and every single nature that we have in the environment. Okay, so we can have a monitoring system, like in this case, you can have hydrocarbon or VOC monitoring system on the vent line. Therefore, you can ensure that the vapor product that goes through here, and what is basically is being released is only water vapor and also moisture, but not the product itself. So by having this monitoring, we can ensure that we are observing the environmental and also the regulation requirement. Previously, when I worked in CCM, we are producing the most toxic gas that we have, which is liquid chlorine. So this gas basically can kill a human being if you are exposed basically to this liquid chlorine in at about 1 ppm and above for a very short period of time. So it was very crucial that that plant to have a good control on chlorine system, which we have multiple detectors, around the system to trigger us if there is any slight leakage, at even lower than 0.5 ppm. We can detect and ensure that it is being attended accordingly, and to continue the safe operation. Not only in terms of release, when you have a chemical plant, basically you will have effluent or waste water treatment system. So it is also important to achieve the correct discharge into the environment. Okay. In this case, many of the industries, they are basically have to release effluent discharge. So at a certain standard, they'll have a standard B, standard A. So all these could be done by having a good monitoring system, instrumentation system. Example, to have pH monitoring, because for standard B, we should be discharging the liquid effluent after adjusting the pH in between 5.5 to 9 maximum. So this is the requirement to be observed in terms of regulation. Okay. So in this area, it's very crucial to have a good selection of instrumentation, because you are directly discharging this into the river. So you can imagine if the selection is not correct and you are discharging acidic or highly alkaline waste into the river, what will happen to all of these living creatures in the river, and which finally will end up in the sea. Yeah. And as for economy, yeah, so this is where I think that most engineers, they will focus, to get uh, uh, the heat network analysis. Not sure whether that you have learned those at this stage of studies. So you have a heat network analysis in the plant to see that do you have any energy that is being wasted that you can recover, and so that you can reduce in using of direct heating from either electricity or natural gas by producing more steam. Yeah. So this is where also basically that you will need the help of control system to have measurement in place, and also control in place. Therefore, you can optimize all of those energy without, not without, basically to have a very less in terms of wastages of energy during the operation. Okay, so I have basically gone through why a process control and system implementation is important, but not only in these 5 areas. There will be a lot more areas basically why this process and also control system is important to be established when we have operation going on in the industry. Okay, I would like to unshare this slide, and I would like to share some of the real experience of selection of instrumentation system that I have done in CCM previously. Okay, so I will unshare this slide. Yeah, Doctor. Any question or not from this slide, if any?
Any questions from anybody? If there's no question, I want to ask one question, Cik Anwar. What is the expectation from a chemical engineer? Like you've been in several different types of plants. What's the expectation towards a chemical engineer with regards to their knowledge in process control and instrumentation? Because we know the hardware is mostly taken care of by electrical engineers, but why would it be important for a chemical engineer to get involved in the control aspect and the instrumentation selection and all that?
Okay, thank you, Dr. Galia. So it's a very this is basically focus answer this not only for process control information. I will focus in a bigger picture as a chemical engineer. What is the expectation? Why a chemical engineer is important, and what is the expectation in the industry of chemical engineering? If anybody would ask me why chemical engineering is important in the industry, you see, yes, as mentioned by Dr. just now, equipment is being taken care maybe by electrical people electrical engineer you have in the plant. Maybe this pump belongs to a mechanical system, okay, which is being maybe taken care by the mechanical engineer, and you will have this processing equipment. Maybe this is also maybe asset under the mechanical system and also the piping. But what is important here is how to keep this equipment in safe operation. You know, what type of equipment should be used. You know, the knowledge is basically rely with the chemical engineer. If you ask the electrical engineer or the mechanical engineer, uh, in terms of operability of the equipment, yes, they will help you. But if you ask them in terms of selection of the right pump for the process stream or the right suitable and also the right control system for the process, believe me, they will not be able to tell you that there is why chemical engineer is important from the end of the process and also production system. You require a chemical engineer to be there, basically to synchronize the knowledge with other engineering area such as electrical, instrumentation, and also mechanical. Therefore,
Cik Anwar, sorry.
Yeah.
The sound, there's some disturbance in the sound. Okay, can you try again? Because it was very difficult to hear you because suddenly there's some macam the sound quality was very bad.
Mungkin sebab video.
Okay, now it's better. Okay, now it's better.
Because the bandwidth sometimes is not so strong. So
now
that's
it's
why.
good. Okay, now suddenly it's good. If you can, you can repeat. I heard that you to integrate the knowledge with those from other
engineering. Yeah.
Can you go through that part again?
Okay, so there is where that a role of chemical engineer is important here to integrate the knowledge with other engineering field such as electrical, instrumentation, and also mechanical, so that you can design the process from end to end uh, uh, with all these aspects in place: safety of equipment, the personal specification, the quality aspect, the operational constraint, and the legal aspect requirement, and also the economics. So all these, if you want to have all these, then definitely you will require a chemical engineer at center of this all engineering principle, so that you can achieve the objective of this operation. So chemical engineer is basically a universal engineer for me when it comes to all these process system. They're the one that will determine the selection of the equipment, the material of the piping, the sizing of this drum, the sizing of this pump, and also the loop of control system which is required. Therefore, you can address minimally all these 5 aspects of the plan. Is that answer the question?
Yes. Thank you very much. Okay, we go ahead. We would like to very much to hear your experience in instrument selection.
Yeah. Okay. So, how to unshare this as well.
Okay, if you want to stop sharing, you go to the top. There's a, you know, you are viewing the screen view options. You will come down and then you can stop sharing there. It's from the top.
I couldn't find stop sharing, but I just click the new share, see whether it
Yes,
will
new share,
replace.
new share would also be fine.
Okay. Can you see now the table?
Yes, but it's very small.
Okay, just try to enlarge. How about now?
Better. Yes. Thank you.
Okay. I do not have, I didn't collect much example because, I was quite tight in my work for the past few weeks. But yes, there are several examples here in terms of the selection method that we have used when we need to uh, design an instrumentation system. Okay. Okay, so we will just define, the characteristic, the medium, the measurement, what we are looking for, the method of measurement, and also the specification of the instrumentation, and the reason for choosing those. Okay. It's a bit simplified and not so technical. Therefore, we have an idea when we are going to design a process design system. What are those things that we need to take into our consideration? Okay, we have a gas medium. Here will be, to be exact, will be the liquid chlorine. Liquid chlorine. Okay, so for liquid chlorine, so this instrumentation to measure the flow of this gas. It is basically uh, highly corrosive, and also it carries a lot of moisture, and it is also quite hot at the temperature of above 80 degree. Okay, so the method of measurement will be using a differential pressure transmitter, and with orifice in place. So how does it measure? Basically, pressure drop across the orifice. It will be measured, and also will be converted to flow. Okay. Do not worry much about all those calculation, because when we work in industry, what we normally do is basically we work with the instrumentation provider. We will give our piping design, what is the size of the piping, everything, and they will basically help us in terms of getting this right sizing of the orifice, and all those calculation of pressure drop and converting those into flow will be embedded accordingly into the instrumentation system. So yes, you have to know the background of it at this moment. Therefore, in future, you will be appreciating the knowledge when you are in the field. At least you can challenge the supplier if it deems that you have some doubt on their calculation and so on. Okay. So what are the specification of the instrumentation that we are looking? So the range of calculation base will be on the inlet pressure, the pipe size, and also the flow rate to determine the size of orifice. And the second thing, in terms of specification of the wetted part, when I say the wetted part here will be the orifice, what will be the orifice that is suitable, how to choose that orifice material. That will be depend on the uh, uh, MSDS or the safety or sorry, we don't use MSDS anymore. We use SDS, safety data sheet of the gas. So if you refer the safety data sheet of the gas, what you can safety data sheet is basically the birth certificate of the gas that we have. Okay, so it will tell us the characteristic of the gas, the condition of the pH, and also the nature of the gas, and from there we can determine what is the best material that we can have for this orifice. Okay, so for chlorine, in our system in CCM, normally the material that we choose will be exotic material, which will be material like if the chlorine have very high temperature and it has a very high moisture, then highly corrosion resistant materials such as titanium will be used, or tantalum will be used in the instrumentation system or the piping design system, so that it can last uh, throughout the life cycle of the plant. So you will not end up to change those, after 3 years, 4 years, or 10 years. So reason for choosing this measurement system or instrumentation system. So it is the most accurate method, and also cheapest. You see, so what we are looking here is in terms of cheap, and also the most accurate. And now you will get confused now. Just now I mentioned electric material, then I mentioned titanium, and that is not cheap. That is very expensive. But why I say cheapest now? So the reason is, they say that you buy an equipment for 100 ringgit, but it lasts only for 10 days. Okay, but I buy a equipment maybe it's slightly expensive, like 1,000 ringgit, but it lasts maybe for 10 years. So now, which one is cheapest? So that is the cost benefit evaluation that I am comparing here when I say it is cheapest. Okay, and it is also cheapest compared to mass flow meter or vortex meter for dirty gas. So the gas just now, when I mentioned it's highly corrosive, high moisture, it has high temperature. So we treat this as a dirty gas or wet gas. Okay. Normally, this gas will carry sludge from the piping. You will have, slight deterioration of scaling that will be carried over with the gas, and it will disturb the flow measurement if we use a vortex or mass flow meter. Yeah. So that vortex and also mass flow meter design actually is not really suitable for the dirty gas. Yeah. So it is more suitable for clean gas, which will have less moisture, slightly lower in temperature, and also the other corrosive character. Okay, and if you choose the wrong selection here, what will happen? So the system reliability. So this is the table that my technician did in earlier days, you know. So in simple word, for them, you know, easily get choked and also give fault reading. So what does it mean? That it will impact the reliability, the smooth operation. So whenever this happen, what the impact to operation? Operation, they will have hiccups. They may need to stop the gas flow operation. When you stop the gas flow operation, you know, the downstream operation also will be impacted, and it will cause instability in plant operation. So that will be difficult later for all the operators, technician, you know, the maintenance support to attend the situation. So, any question from here?
Any questions? Anybody? Okay, saya rasa boleh go on dulu kot, Cik Anwar.
Okay. Okay.
Sorry, Mr. Anwar.
Yes.
I would like to ask. Okay, my name is Ashraf. Okay. Actually, for some of the instrumentation item, okay, at some point they need to be replaced or repaired, right?
Yes.
So during the process of repairing or replacement process, so did it involve a shutdown or minor or major shutdown? Or your plan normally do you have another plan?
Okay. Instrumentation replacement in the plant. Okay. Normally, when it comes to end of life, end of service life, yes, we need to replace instrumentation or maybe part of the component of equipment. I will be more general telling here about equipment, not only instrumentation, because this involve a lot of other equipment, even though it is not instrumentation. So how that we replace this? Yes, sometimes we take opportunity to do it during our annual shutdown. Why? Because during annual shutdown, you will have numbers of days that, you know, the plant will be out of service, and that will be the most safest period to carry out service work, replacement work. Why? During this situation, the entire plant system piping, you know, will be flushed out. Decontamination process will take place, and replacement of equipment could be done. But that involves a lot of study before we do that, because you will not have annual shutdown any day. So annual shutdown normally will take place maybe every 15 months. So what if any instrumentation require replacement out of those period? So what we normally practice is we will run a risk assessment to the stream, and we will see whether we can bypass the operation, and also take out the instrumentation for fast replacement, such as what those Formula One cars does at the pit stop. Yeah, so we will have that kind of activity by doing a proper risk assessment, or whether we still can use that instrumentation by understanding the bias that currently that you have, and you ensure that there is consistent bias in the system, so that you still have a reference of measurement. Yeah, Ashraf, did I answer your question?
Yes, you answered correctly. Just another question, because actually I think you have a lot of experience. So in your past experience, did you face any problem with the instrument? And normally, do you have any scenario that because of the failure, it caused the plant to shut down, unplanned shutdown?
Yes.
Yes, that's my
Another
question.
good
Thank
question.
you.
Yeah. Good. Okay. Yes. Yes, we had. I have a lot of experience or that situation when it was in the early stage when I joined CCM. Okay, so we have instrumentation failure that caused plant shutdown, but we also have instrumentation failure that also caused people to be sent to hospital. So that experience is really valuable for me lah. Uh, uh, After that, there is a lot of lesson learned um, down the road, by understanding all of those situations. So I would like to just give a conclusion, basically, from that incident. Whenever you have a process plan, you have a system in place. Another aspect to ensure that the system, which is consists of people, process equipment, and also the product working well and coordinating each other is the maintenance program. Yeah. So this aspect of maintenance program, the asset integrity and also reliability program must come into picture, so that you can avoid all those scenario which is mentioned by Ashraf just now, having unplanned downtime, and also another scenario that I have mentioned, unintentionally we injured people's life along the way. So yeah, so those experience that I had earlier. Yes, so maintenance program, asset integrity, and also reliability program to be determined. It is quite difficult for you to have all those programs in place and working 100% well, but at least you should focus on critical area of the plant and make sure that it is working, and also the program is addressing the possibility of having major accident hazard. Okay, Ashraf, is it okay?
Okay. Thank you very much, Mr. Anwar.
All right. All right, so I will just continue into the second medium of liquid here, which is highly corrosive and also high temperature. The intention also to measure the flow. Okay. So this time we choose vortex flow meter rather than the mass flow meter. Okay. So why we choose vortex? Because vortex can be used for a wide range of fluids, liquid, gas, and also steam. So vortex meter are essentially a frequency type of meters that involve pulsation, since they measure the frequency of vortices or the pulsation generated by the bluff body of the shadow bar. Okay, so the range of the calculation will be based on the inlet pressure, the pipe size, and also the flow rate to determine the size of orifice and also the buffer or the shader. And the wetted part also will be chosen on the liquid or specification from the SDS. So, the thing is, when we choose in terms of the sizing, you will see, the principle is basically will be the pressure, the pipe size, where we will convert those parameter into the flow when we are not using the mesh flow meter. Yeah. So you need to convert, other parameter like pressure, like temperature, and also some other design to get the flow. I think that you have learned those in your studies at this moment. Okay. Okay. We have also another gas stream where we are measuring pressure. Just now we are measuring the flow, but this time we are measuring pressure. So this is also wet gas pressure transmitter. So this pressure transmitter is very, very important. It is a seal rated pressure transmitter. So when I say a seal rated pressure transmitter, so the reliability is expected to fail only once in 10 years. So if I'm not mistaken, it's a seal rated. I couldn't recall, maybe 3 or 4. Yeah. So it's a seal rated pressure transmitter. So why we choose a seal rated? Because we are highly reliable. Because this string, if you have a frequent failure, you will damage the upstream equipment such as the electrolyzer, the membrane, which may be in terms of the cost of damage will be very, very huge and substantial to impact the company performance in terms of profitability and also the company reputation. So that's why we choose a seal rated pressure transmitter. Okay. So the functional principle of this resistive pressure sensor is very simple. The pressure sensor, okay, we use a pressure sensor, convert the mechanical pressure value into proportional electrical signal. Normally we convert 4 milliamp to 20 milliamp signal from the designated pressure range. The pressure sensor typically consists of a stable main body and also a thin diaphragm material, which is directly mounted in line to the piping system of this gas stream. So the specification, basically the range of calculation based on the inlet pressure, the pipe size, and also flow rate to determine the size of the sorry, it's not the orifice, it's the diaphragm surface area. Okay, on the, and also the material of the diaphragm will be chosen based on the gas, in this case chlorine. So normally material like tantalum sheet will be the diaphragm. And why the reason that we choose this, the most accurate and also reliable. So here comes the reliable method of measuring the pressure. Then why is it important to reliably measure the pressure? I mentioned just now, it is not only used to monitor the pressure, but it is to basically safeguard the downstream equipment in terms of maintaining or monitoring and also controlling this header pressure of this hydrogen and also this chlorine gas. Okay. All right. So you have another stream with liquid, but we are measuring the not the flow, but the pressure of the liquid. Okay. So this is also this same principle as above gas, but this time it is liquid, and again it is similar to this line of explanation that I have given. It is to have accurate and also reliable method, and the specification selection also will be determined of the inlet pressure, the pipe size, and also the flow rate, and also the selection of the diagram will be depend on the liquid. So in CCM we have three type of in process liquid. You will have water based. You will have acidic liquid. When I say acidic, pH will be 1. Liquid like hydrochloric acid at a concentration of 33%. You will have the caustic, or sodium hydroxide at 20%, 30%, and also 49%. Okay, this is a highly what do you call that? High in pH. pH will be on above 11, which is about 12. And then you will have a mixture of those like sodium hypochlorite in terms of liquid, another liquid which is also highly nature of having corrosive and also high temperature. So the temperature that we have here is in the stream of in process is will be more than 70 degree up to 85 degree for each liquid based on the area of the process. So that makes the selection of the material, and also the cost involved. It is huge in capital investment, but when you achieve the reliability over a period of time, that capital investment actually it is not so huge because you will gain from other aspect of the operation, such as lower downtime. You do not have to keep a lot of spare part of those material. You will basically enjoy higher yield of production, and importantly, you will have more time to think of other process optimization, development in other area of processing of the plant. Therefore, it will contribute in terms of the sustainability of operation, as the operation aging. Okay. So anything that you need clarification from my explanation, that by having a reliable operation, those area that we will gain. This is basically my experience throughout the years. Sometimes people company very reluctant to do the capital investment. Because they don't see that it is important, but it is the role of the chemical engineer actually to put that clear justification, actually what you are going to achieve by doing this. Any question or any concern on that area?
Encik Anwar,
Yeah.
when you want to select the instruments,
Yeah.
or what do you do first? What do you look at first in selecting the possible, because there's multiple choices that you have to make, right?
Correct.
Yeah. So what do you look at first in coming up with the criteria? What would be included in your criteria normally?
Okay. So first, most is the objective why we need that instrumentation. Let's say that this instrumentation is being used to measure the final product quality. You are having a continuous operation, and you are directing the product directly into the storage tank after the final process. So you need to have instrumentation to measure the final product quality. So that will be the first critical parameter that we look where this instrumentation and what it is being measured. Okay, so that first criteria. So if it's measuring a very crucial parameter that we will have the impact either the upstream, in this case the storage tank, or downstream of the process. In this case is the whatever in process material that we have, then the selection of the instrumentation will be set to get accuracy and also reliability. This is where that I always go for SIL, SIL, and SIL rated equipment. So this is pretty much in the industry, the failure rate is already being determined. You can have a failure rate only once in 10 years, or maybe a failure rate of one in maybe in 5 years. So you can source on those kind of instrumentation in place. And secondly will be the cost, the cost of the instrumentation. And then also will be the material of construction of the better part of the instrumentation. Okay, Prof, did I answer your question?
Okay, yes. Thank you very much. It's always about the objective, yeah?
Yes, of
What
course.
to get out of it.
Yeah.
Yeah. Okay, thank you very much.
Right. Okay, I shall continue with the next instrumentation that we installed. Okay, in the electrolyzer header. Okay, this instrumentation is basically to measure the stream that we have. We call it brine, which you have chlorine after chlorine traces of chlorine in the stream. It's a basically dissolved chlorine in the salt water after the electrolysis process. So we used to change this instrument every 6 months before we come, changing to the one that we have here, which after that it lasts for at least 2 years. Yeah, that is a very substantial improvement, from 6 years to about 2 years. So previously that we have direct mounted RTD into the stream that that caused the sensor to fail every 6 months. Okay. So that was the earlier design of the plant. It is, determined that, this RTD will fail every 6 months, and they have put into the design. And the range of, basically range of operation of this temperature will be 0 to 300 degrees C. So the upper part, the listed range also selected according to the range of temperature. Therefore, this RTD can measure the temperature accordingly. Okay, so we change this material, and also the method of measuring this temperature, and also the thermal well material into titanium. So, the cost, yes, double of the cost that we have from the existing RTD, but the reliability actually is more than double that we had from the earliest RTD that we use. So these are very simple initiative, that a process engineer or the chemical engineer, they can focus, and implement in the operation, that will be beneficial for the operation and also beneficial for the cost of operation. Okay, so now I will share on the caustic density analysis control. Okay, so measuring the density of this product is very crucial. As I mentioned just now, when Prof. Idea asked, what actually our criteria, the objective of the measurement system. So in this case will be the density. So we sell this product based on density. So it is very important now that we have the right density. So I always remember, when you sell anything, you shouldn't lessen the weight of what you sell. The Prophet mentioned that. So by having that understanding, I also thought that you should also use that in your daily life, even though you are selling this product to customer, to give the right agreed density, because it involves exchange of money in this case. So it's very important for you to achieve the right range of density to be given to the customer. So this emitter basically consists of a detector, a converter. Okay, the detector has a vibrator and also RTD, and output detected density signal in measured in frequency and temperature signal voltage. So you have frequency and also you have temperature signal converted to voltage, and it goes to the converter. So by calculation, it will convert all these parameter to get the density of caustic. Okay. So it is directly mounted on the product pipeline. So it is inline basically, and it is a continuous measurement, and the measurement is transmitted every second. You can imagine, you run the plant 24 hours a day and 360 days at least. So it is continuously sitting in the stream day and night, at a temperature about 45 to 50 degrees C daily, and giving a continuous measurement to the distributed control system. Yeah, so that we are very sure that we are selling this product at the accuracy of measurement of 0.5% weight over weight, and we have an alarm really incorporated in the system, so that it will take care the output or the downstream of the system, and also the upstream of the system. So again, reliability of product quality is important here. This case, price factor not critical. Any guess on how much that this density meter will cost?
Must be very expensive.
Yeah, it's very expensive. You can buy what do you call that? A fully equipped MyV. Yeah. Okay. But with MyV, definitely you can go around. But this one, it just stay there on the pipeline. But because of the reliability of the product quality, that's why I say the price factor is no more a critical factor here for us to have. And also in terms of selling point, so we are giving the right density to our customer. Okay. So if customer happy, then of course whatever things along the supply chain also will be happy. Okay, then we can have a win-win situation in the business. Okay.
Oh, there's a question here, Encik Anwar. From Tanuja. When it comes to mixed phases, let's say you have multiple phase like liquid and gas at the inlet of any equipment, what are the criteria to be considered? What do you want to measure, Tanuja? Flow rate ke apa?
Yeah, like the one that Encik Anwar showed just now, it's like the liquid and gases only, right? Respectively, right? But what if like our inlet is in mixture? So how do we choose?
So normally in a stream of mixture, we do not have how I put this. So if you have a stream of mixture, you are going to measure either the liquid or the vapor. So in this case, in a mixture, normally what you measure is the pressure in normal situation, because it is still not in a final product condition yet. So you know that any stream have mixture, finally it will end up to be separated by end of the stream. You will not have both because either you are taking liquid out of it or you are taking vapor out of it. So either one of these. So if it's liquid, then you focus on the instrumentation required for you to measure that liquid. So if you wanted to measure the density of the liquid, then focus on the instrumentation that would measure that the density of the liquid. If you taking up the vapor as the product, then what is important for that vapor? Is that the purity of the vapor that you are going to measure, meaning that that vapor having less moisture? Then you need to have a good moisture meter to be selected for that particular stream. So normally, if you are talking about two-phase, you will have this kind of decision making when it comes to the selection. When two-phase, you have a in process system. Let's say that in this case you have the liquid chlorine. Liquid chlorine basically at the initial stage of the process, it is in a gas condition. Okay. So when it comes out of the electrolyzer, it is a very hot gas. So along the way, we will cool down those gas. So when you cool down those gas, you will have a lot of moisture. So we will have a moisture meter installed to measure that, amount of moisture that should present in the downstream of the downstream the chlorine gas. Why? Because chlorine and moisture is very aggressive. So the downstream of the plant, maybe you will have other instrumentation and also other piping system, which will not allow to have a lot of moisture content to be carried over. So you will have moisture and also chlorine gas. In this case, you have a two-phase. But what you are going to measure, you are going to measure the moisture content in the gas. So you will select a moisture meter. So this is one example that you can determine what actually you wanted to measure will determine what you want. Is that answer, Tamija?
Yes, Encik Anwar. Thank you.
Okay. All right. Okay. So I will continue. Okay, so the last one, the last but not least, the sodium hypochlorite. So sodium hypochlorite is actually Clorox, Clorox, the one that you buy in your that you use in your household, but that is maybe already being diluted for maybe 100 times most probably. Yeah, the one that you use is only about very low in concentration in the household. But the one that we have in the plant is basically the highly concentrated sodium hypochlorite, which if it drip on your clothes, eventually your clothes will be torn apart. Yeah. So it is very important to maintain the strength, the concentration of this sodium hypochlorite in the absorption. Okay, so this how we produce sodium hypochlorite is basically we absorb 20% caustic into chlorine, tail gas of chlorine. Tail gas of chlorine from our system, because we cannot release this chlorine into atmosphere. Chlorine supposed to be in the closed system of the operation. So there is no release for chlorine. So if you don't do anything with this excess chlorine or tail gas of chlorine, it will build up the pressure in the system, and eventually the plant cannot run. So what we'll do with this excess chlorine, we send this chlorine to be absorbed in the absorption column. It's a packed absorption column. So you have a chlorine stream coming from bottom, and you have a shower of caustic soda 20% from the top of the column. You will have a bed in between of the column, packed column. Yeah. So so that your chlorine gas could be absorbed effectively into the 20% caustic. And after we absorb, we need to maintain the concentration of this sodium hypochlorite. So this is basically a byproduct from our process. So we sell this also as one of our product because there is the need in the market for this. So we make sure that the concentration we sell is within the requirement. Is about 13 to 15% concentration. So after absorption, you will have this density meter at the outlet of the product line. Before it could be sent into the storage tank. So the product will be recycled within the absorption column until it achieve the right ratio of chlorine gas and also caustic 20%. So basically, this is cascaded with the stream of chlorine and also stream of inlet caustic. So one instrumentation, they are doing maybe 3 or 4 jobs here, to achieve one single output of concentration. So the selection of this instrumentation is a very precious material like platinum, silver, and also gold is used as the measuring electrode. Besides admission and also release of electron, these metal have chemical reaction with process fluid under polarization effect. So it's a very sophisticated instrumentation. It goes by electrochemistry here to give you the output reading, okay, by having a redox potential from these electrodes, and it will convert into a electrical or electrical signal. Then from there, the reading will be obtained. Okay, so again, it's a reliable of the important here is the reliability of the product quality, and also in this case also the price factor is not critical when we do the selection of this equipment. Okay, I think we are at the end of the of my presentation. So I would like to share all this material from my previous experience. Therefore, it will be beneficial, for students, so that you can accordingly use this knowledge to use in your project. Okay, Prof, can you just give me 5 minutes? Not 5 minutes. I mean about maybe 2 minutes.
Yes, actually, there's 2 questions that just came up.
Yeah, understand. Just 2 minutes. I'll be back.
Okay.
Okay, just 2 minutes.
Okay. If you have any questions, please, you need to type you can type your questions here so that we can pose it to Encik Anwar. Yeah. Okay. Farid, anybody else with questions? Okay, there's 3 questions now, in the chat area. If you have any other questions, please type it now, because otherwise you will not have a chance to ask Encik Anwar anymore after this. Are you ready to take the questions, Encik Anwar? Oh, you're muted. Okay.
Okay,
So,
all right.
from Mugilan, it's about choosing pumps and having different powers, and the cost is also different. How do you identify according to the process about the pump selection? Is there anything specific that we need to consider in choosing pumps?
Okay. Normally, ask question to ourselves. Okay. Normally, this is how I do when I do the pump or any equipment selection. Okay, so why we need a pump? So I need a pump to transfer liquid from point A to point B. So, so where is point A and also where is point B? So there must be a distance to travel, correct or not? So if you have distance to travel, what is important here? It is the head or the head requirement of the pump, you know. So what you should consider is basically the pump head, because the distance of travel basically will determine what are the head of the pump that is required. Number dua, secondly, is how fast you need to transfer the pump. So when you ask the question, how fast you need to transfer, then that will determine the downstream condition and also the upstream condition, because you do not want to oversize this pump unnecessarily. So you need to understand the process that you have downstream. What is the level control requirement? What is the buffer volume you need to maintain in the tank, and also the point that you transfer, so that effective flow rate could be determined later for this pump. And then the material construction of the pump on the wetted area of the pump. This is basically the pump casing and also the pump impeller. So as I mentioned just now, go back to the SDS of the stream that you have. Check on the characteristic of the medium, and from there you can have the material selection, material selection metrics. Then you were able to choose, the right material. So when I say the right material, it not necessarily to be all those extreme material for you to achieve the reliability, not necessary. So that you have to choose the right material so that it can last approximately, minimally 5 years to 10 years for the operation requirement, because a pump will not be a chemical pumping system will not be cheap, so that you have to take into account that whatever that I choose, it should at least serve 5 to 10 years in operation, based on where you are going to have this pump. Last but not least, the environment. Sometimes you have very corrosive environment, which you cannot avoid. Like my case in CCM, you have this where you charge the salt, in a pool of hot water. You cannot enclose this, because you need to charge like 3 tons of salt in one go. There is no any delivery system can do that except you're using a manual loading system. Yeah. So when you have a salt environment, your environment is very, very corrosive. So you have to choose the not only the vetted area of the pump, but also the external material of the pump, which can last that environment. Is that okay, Mugilan?
Okay, Mugilan.
Yes, Encik Anwar, thank you so much.
Okay.
Okay, there's another question by Nur Ain. She says that there's nothing mentioned about level measurement.
Uh,
Anything you can share about selecting the appropriate instrument for measuring level?
okay, all right. So, uh, sorry that I do not have an example for the measurement of level, because level measurement in CCM previously not a big issue, as you know we use diaphragm type of level transmitter. Okay, so this transmitter is basically it is located at the underneath at a very low level of a tank, but obtaining the static pressure of liquid in the tank, it will be converted into the measurement of the tank, and considering the density of the liquid, so it will be again converted into the tonnage, of product that we have inside the tank. So nowadays in the market,
Pressure, Anwar?
again,
Dia guna differential pressure lah.
yeah, basically we guna differential pressure lah, the static head. Okay. So it will convert lah, but normally tank level, it depends. So you can have level in terms of percentage, how many percent full, 60%, 70%. It also can be indicated. But from there, if you know the density of the liquid, you can convert that into the actual mass amount of liquid that you have in the storage tank. Yeah, like tonnage. Yeah. Okay. But nowadays in market, you have a better option of measuring, level, such as the what do you call that? Infrared, and also ultrasound. Yeah, ultrasound. It is also widely used now in the market, which is it is directly mounted on the top of the tank, and from the ultrasound signal, actually you still measure the gap between the liquid in the tank, and also the available space in the tank. So it is basically, this instrument is not in contact with the liquid itself. Yeah.
But then if it's noisy process, then it will be problematic if the level is choppy.
Yeah, there will be some interference.
Okay, there's another question. It's on when you mention the environment and how control you have to be, is responsible for ensuring that we do not pollute the environment. Do you conduct analysis on wastewater, or is it another apa benda ni, or any other thing lah? And I think it's mostly on emission juga kan, if it's at the environment. And how is control, how much involvement of control is in it, in making sure that we take care of the environment? For example, do you conduct analysis? Secondly, how much do you encounter usage of optical sensors in your work? And last question, how much do you encounter complex instrumentation? Like in the example of the hypochlorite concentration before, when you shared the concentration measurement before this.
Okay. Okay, so in terms of the environment, and also how control system are responsible for it, and how much involvement of control in this. Okay, and you are giving example here, conduct analysis of wastewater, or is another team. Okay, when you have effluent system, when you have a wastewater system in the plant, normally during the early stage, the EQA is already determined, the type of discharge that you should have for this effluent. So this is based on the characteristic study of the liquid discharge. So in case of the plant that I was working before, the requirement of discharge is under standard B. This is basically the requirement of pH to be maintained within 5 to 9 upon discharging of the product. And other requirements such as COD and also BOD, which we know that in our process, it is not going to change so much because there is no biological impact matter, as this is an inorganic chemical that we have in our stream. So it will be no much change. So normally for that kind of measurement, we will take it weekly and send to third-party lab for monitoring purpose. But for the pH, it is basically being measured at the stream itself, where you have continuous monitoring on the discharge, so that the pH is basically between 5 to 9. And let's say that you have a pH outside this operating envelope. The downstream control system will basically shut the valve, and it will not allow you to do the discharge until you get the pH back into control. Yeah. So this is where the control system design is having the responsibility to ensure that you only discharge accordingly to the legal requirement. Actually, this is not being stated anywhere, this requirement, but this is how responsible the company is, that they would like to have this control system, just to ensure that if people fail to manage this, you have another layer of protection. The control system will be there to ensure that zero non-compliance in terms of discharge. The second question, did I answer the first question?
Got it? I think okay, good.
Yes, yeah.
Okay. So for the second question, how much do you encounter usage of optical sensor in your work line? We do not have optical sensor what do you call that, in my plant previously. If I'm not mistaken, optical sensor use mainly in moving automation as a limit control for robotic arm when it moves. But in our plant, we do not have everything inside the pipeline. Mostly, the liquid stream is moving from one place to another place. So I could not comment much on this optical sensor. And the chemical plant that you have, basically the instrumentation system will be mainly on pressure, temperature, density, and also level. So these are the few areas that commonly we will see. And the last question, how much do you encounter complex instrumentation, like example, in hypochlorite concentration. Okay. Complex instrumentation. When you have complex instrumentation, meaning that the process is very critical. It can bring the harm to people, environment. If you don't manage this properly, maybe damage in terms of upstream or downstream asset. So if you have this, then the instrumentation will be complex because it need to have numbers of loop to take care various area to ensure things are in a smooth operation. In CCM, we have 1, 2, 3, 4, less than 10 of these. You cannot have many of these in the operation. We try to have a proper level so that it deems to be, it is critical. Yeah.
Okay. One last question. This is on Dr. Yusuf, you want to ask this question yourself? Yusuf?
Yeah, okay. Assalamualaikum, Cik Anwar. Okay, I have a question actually, because since in your table for the first two row, you mentioned that for gas, for the flow measurement, for gas we use orifice, and then for the liquid we use a vortex flow meter. So I'm just wondering whether this is a common practice throughout all field in chemical engineering, or is it very specific to where the fluid that you are working on? Because since we know that we have quite a few different type of flow meter. From the top of my head, I can remember like electromagnetic. We have the ultrasound. We have rota, pitot tube. So we have different kind of flow meter. So is it the common one we use is orifice and vortex, or is it depends?
It depends, actually. It is not common. As I mentioned, these two stream, basically, you have a highly nasty fluid. They are quite stubborn. So we choose this type of flow meter so that, it is giving us a liability of measurement. And it basically, it serves to be suitable for that liquid. So the gas actually here will be the chlorine gas, and the liquid here can be either hydrochloric acid, caustic soda, or sodium hypochlorite. So that's why we choose this type of measurement. Let's say that you wanted to use a rotameter here. When you have critical medium like this going through a rotameter, and if the rotameter break, you are going to expose the liquid into the safe operation of the people. So it is not suitable to have a rotative type of instrumentation here. So it should be contain the liquid in the system as much as possible. Yeah. Is that okay?
Yeah. Very okay. Thank you, General.
Yeah. So, okay. I think we have, it's almost 2 hours now. Sorry, Cik Anwar, we have gone over time, but thank you very much for all your sharing. Any last questions before we end the session? Anybody? Okay, now before we end, I just have one question. How often do you recalibrate your instruments? Do you do it every time there's a shutdown, or instruments can run away, the signals can run away. So how often do you need to recalibrate the instruments?
Okay. You can have that.
Noise is bad.
Because feasibility involve, cost and resources, so everything should be determined that you have that, the right frequency. Okay. So for instrumentation calibration, minimally is 6 months, from what that I have experienced. But sometimes the supplier of the instrumentation will give you the frequency of calibration. As you know, they are the maker of the instrumentation. Sometimes they have already specified it has to be calibrated using certain period of time. But the actual calibration and also verification should be determined by operation after it is being installed, after we run the stream and we do a verification process. So then only we will come into a conclusion. Actually, this instrumentation validation requirement at what frequency that we need to fix. So once you do the verification, from there you are able to basically determine the right frequency requirement for the calibration. So this will be formulated into the maintenance module. Therefore, the field instrumentation engineer will not forget to do the calibration accordingly. If we have frequency like 3 months, we have 6 months, and then we have 1 year. Some of the equipment we only calibrate every 2 years or so. We have. So if it's in conjunction with the annual shutdown, then we will calibrate accordingly. But let's say that you need to do the calibration during the plant running. Yes, it can be done, but it required proper process assessment, also risk assessment to be conducted, because it will impact the downstream and also upstream of the process when you take out the equipment for offline calibration. We also use other method in terms of calibration. We have multiple equipment upstream and also downstream. So they say that the downstream equipment are already deemed for calibration. We will see the value and we will compare to a upstream value of instrumentation, which still within period of calibration. So these are also a few things that we use, whether really calibration is required at that moment or not, or we can wait before we do the calibration or taking it off offline. Okay, Prof.
Okay, thank you very much, Anwar. So I think we have come to the end of the session. So I think we really appreciate your sharing. Thank you very much. I'm sure everybody here appreciate your what you presented today. I think it's very, very useful. And I hope it will, inshallah, I think it will help the students to do their project. Yeah. So thank you very much again. Inshallah, everybody, I think you have benefited a lot, right? So so I think we will end the session for now. Thank you very much, Encik Anwar. Inshallah, I will talk to you again. Okay, everybody. Thank you for coming in to and listen. So, Assalamualaikum warahmatullahi wabarakatuh, and good afternoon, everyone again. Okay, have a nice day, everyone. Terima kasih Cik Anwar.
Waalaikumsalam, Doktor. Thank you.